We're going to do science right now. So we're in chapter 2. We're going to read a part of the chapter together, and then you're going to work on this worksheet, number 6. God designed the atmosphere to sustain life. So let's begin on page 10. Let's look at these words. Most of these words are in the later part of the chapter, but let's go over them so you know how to say them. We've got atmosphere. We all know what that is. We read about that when we did our word study. We've got troposphere, stratosphere, mesosphere, thermosphere, ionosphere, exosphere, magnetosphere. That sounds like something from a Marvel movie or something. Aurora borealis and aurora australis. So you know what those are. The aurora borealis are those pretty green lights that wave and wiggle up in the sky way up north in Alaska. All right, so let's begin reading. Oh, and the challenge word is lapse rate. We'll get to that later. When we think of the earth, we usually think of the solid ground on which we stand. This ball of rock we call Earth is a very special place. Unlike the other planets in our solar system, Earth has an atmosphere especially suited for life. That's what our worksheet is about, how our atmosphere is specially suited by who? I'm not sure. Maybe a God guy? I think so. The atmosphere is the layers of gas that surround the planet. These gases keep close to the surface of the Earth by the Earth's gravity. The Earth's atmosphere consists of 78% nitrogen, 21% oxygen. If you add those two together, that comes up to 99%, and 1% other stuff, like hydrogen, helium, argon, and carbon dioxide, the stuff we breathe out when we breathe. In with the oxygen, out with the carbon dioxide. This combination of nitrogen and oxygen is the ideal atmosphere for life. Nitrogen is a relatively non-reactive gas. That means it doesn't explode. Its purpose in the atmosphere appears to be to dilute the oxygen, to kind of keep it from being pure oxygen. Nitrogen also helps protect the Earth from gamma rays from the sun. If the oxygen concentration was more than 21%, fires could easily burn out of control. Now you think, well, yeah, we've got wildfires burning out of control right now. But no, if you turned on the gas stove in your kitchen, or there was a spark when you walked across the carpet and touched the doorknob, that might turn into a fire if we lived in a higher percentage of oxygen. Yet animals and humans need oxygen to breathe, and 21% appears to be the ideal concentration. So the first question on your paper says, do other planets in our solar system have atmospheres suited for life? What does it say on the fourth line? Unlike the other planets in our solar system, Earth has an atmosphere specially suited for life. So that means Earth has this beautiful life-sustaining atmosphere, but it's different. It's unlike all the other planets, so none of the other planets do. If you remember, some of them have no atmosphere and some of them have a poisonous atmosphere. So answer that question. The rest of the questions you're going to answer on your own. I'm not going to stop and explain them to you, but you'll see them in the reading. The Earth's atmosphere not only provides needed oxygen, it also protects life from several harmful effects of space. First, the atmosphere insulates the Earth from the extreme temperatures of space. The atmosphere keeps the surface temperature of the Earth relatively the same. Temperatures on the Earth range from -60 to +40 degrees Fahrenheit. So -60, like down at the Antarctic, at the South Pole, and +140 in the desert. It got up to 130 in Death Valley, California a couple of weeks ago when we had that really hot weather here, and it was 109 or so here. It's 130 in Palm Springs. But let's look at what happens on other planets. It also says that the temperatures are more likely to be, see right here where I am? Sorry, I got lost for a second. At the extremes, and are more likely to be between 0 degrees and 100 degrees. Well, here it gets a little hotter than that, but most days not much more. However, on the moon, see where I am? On the moon, which has no atmosphere, the temperature can be as much as 260 degrees in the sun and negative 280 degrees on the side facing away from the sun. So the Earth's atmosphere protects us from these extremes of temperature. The atmosphere also protects us from the vacuum of space. There's no air in space. The air pressure provided by the atmosphere is necessary for our bodies to function correctly. Out in space, there's no air pressure to keep our bodies together. Also, the atmosphere protects us from harmful radiation. The ozone in the atmosphere filters out much of the ultraviolet rays from the sun. These rays can damage our skin and cause skin cancer. Finally, the atmosphere protects the surface of the Earth from many impacts. Just compare the surface of the Earth with the surface of the moon. The moon's surface is covered with craters caused by impacts, meaning from rocks from outer space hitting the moon, and it makes a big old hole. What happens to most rocks that come from outer space before they hit the Earth? You know, let's read it. The moon's surface is covered with craters caused by impacts. Yet relatively few impacting bodies reach the surface of the Earth because most burn up in the atmosphere. When we see this happen, we call them meteors or shooting stars. So that's where I'm going to stop reading to you. We'll work on this worksheet, and then we'll pick up there tomorrow. So you're going to answer these questions based on what you see in that reading we just did. So, and at the bottom is a thinking question. I want you to write 2 or 3 sentences about how the design of the atmosphere shows you God's care and protection of his creation, which includes you.